So we want to talk about the equation of a straight line here. This is a step to talk about the tangents and normals here. So before we start talking about tangents and normals in differentiation, we need to appreciate how to find the equation of a straight line. When we talk about the equation of a straight line, it comes through in the basic state of y is equals to mx plus c, where x and y are variables, right? So these values, they change from time to time. So we don't need to worry much about them, but we need to know that these values, they change. But we need to find the value of m, where m is the gradient, and the value of c, where c is the y-intercept. The y-intercept meaning to say that this is the point at which the line, the straight line, cuts the y-axis. Suppose that I have my Cartesian plane like this, y-axis there, and x-axis there. Suppose this is my point of origin, that's 0, right? Then we have 1 here, 2 here, and 3. Just an example, 1 and 2 here. So if I draw a straight line that is going to be coming through like this, suppose this is my straight line here. So this straight line here is cutting the y-axis at point where y is equals to 1. Yeah. So my y-intercept here, the value of c will be equal to 1, which is the position at which my graph is, my line is cut the y-axis, right? That's basically what we mean when we're talking about the y-intercept. So it is basically the point where our graph cuts the y-axis, which is the point right there, which is this point right here. Oh, come on. I need a different color. Let me see what I can do here. Okay, cool. So here is my y-intercept here, right? So whenever you're given an equation of a line, you need to be able to arrange it in this state. Make sure that the coefficient of y is 1. There is no other number that's supposed to be here other than 1. And it's mx, right? Mx plus c. So what is said to be the gradient? The gradient, we are saying that this is the coefficient of x. Coefficient of x, the number that is tending in for x. Suppose I'm given now y is equals to 3x plus 4. Here I can pinpoint that the gradient is m, which is 3. Then the y-intercept is equals to plus 4. So I can just put a 4 like this, right? My y-intercept is plus 4 like that. I can get another example like y is equals to negative 4x minus 9. Here I can say that my gradient is equals to negative 4 because that's the number that is standing in for x. Then my y-intercept is not just 9, but it's minus 9. That's what I can say, yeah? Then I can get another equation like 3x, or let me say 3y here. 3y is equals to negative 6x plus 9, like this. Here I'm seeing my coefficient of y is not 1, so I will divide this by 3 so as to clear this 3. So if I divide this by 3, everything has to be divided by 3 as well. So these will cancel, leaving me with y being equal to negative 2x plus 3. Now I can say now my gradient is equals to negative 2 and my y-intercept is equals to positive 3. These are now my solutions. Why? Because I had to remove the number that is standing in for y, because y is supposed to be having only a coefficient of 1. I hope that is making sense and you are following through. So that part was, the part that we're just doing is how to identify the gradient and how to identify the y-intercept, which is the one that we're covering with these examples here. So let's now talk about the part of calculating the equation of a line, right? Calculating equation of a line Let's start by the part equal to given 1 point. Given 1 point and the gradient. So suppose that they give me something like there is a point that the line is passing through. A line is passing through the point -3 and 4. Right? Then this is this is the x-axis, this is the y-axis. So the point, the graph, the line is cutting through, is passing through -3 and 4, and its gradient is said to be equal to let's say 6. So check this part. The reason why you are going to be given the point is for you, the point in the gradient is for you to find C. Find C in the equation y is equals to mx plus c. You get the point? So you're given m, you're given x, you're given y. So you need to find c. So just do mere substitution like what you were doing before. Y is 4, m is the gradient, which is 6, x is the -3, so it's multiplied by -3 plus c. So this will resolve to what? That's 4 is equals to -18 plus c. So I'll take this to the other side. So I now have 4 plus 18 being equal to c. So my c is equal to 22. So now I have found the value of my c. I can now go back to the original equation now and substitute the value of c. Remember, we said we need only to find the value of the gradient and the y-intercept. X and y are variables, they will stay like that. So to find my equation of a line, I'll just substitute the values of the value of c to leave me with y is equals to m. I need to place m, which is my gradient, 6. X is a variable, plus c is 22. So this now will act as my equation. This will act as my equation of the equation of the straight line, right? So to just summarize that, if I'm given 1 point and a gradient, I can find the equation of a gradient, the equation of the line by saying what? By substituting x and y in the equation. Mx, it means 6, it means m times x. So that's 6 multiplied by -3. Then you add that with a c. Those are c is the one that we are looking for, yeah? Then we are saying now 4 is equals to 6 times 6, that's -18 plus c. So having that 18, skipping this side, skipping the equal sign to go this side, will now become a positive 18. It's now 4 plus 18, giving us a c. Now I got a c. I substitute now in the main equation. I remove the m and I place the value of m, which is the gradient. But x and y will remain like that. I'll remove again the value of c to place the value of c that I just obtained to get y is equals to 6x plus c. So this is my equation of a what? Of a line. I hope that is making sense. So in the event that you are asked to do something like what? Okay, let me just do this. In the event that you are asked to solve something like this, this is one of the videos that this is one of the sheets that I would want you to work out. Here they are asking us to find the gradient of these lines. So the gradient of this is 3, because that's the value of m. The gradient of this is 2. So the y-intercept here is y is equals to 1, right? Let's just talk about that in a second. If I'm given here, because they want us to find the value, write down on each of these lines the y-axis, and then write down where each of these lines crosses the y-axis, right? Where it crosses the y-axis. It crosses the y-axis here at y is equals to 3, at y is equals to 1. You get the point? At y is equals to -2, at y is equals to -5. So you can just identify the rest of these guys, yeah? Then this one now, we want you to write the equation of the line now. You get the point? Given the gradient is 3 and the y-intercept is 6. This is now pretty simple. Why? Because the gradient of the line is y is equals to mx plus c. I'm given m, I'm given c. So it's now simple. Then here, does these points pass through the line? Don't worry about these ones. So that's basic. So you see these ones now. Here you are given 2 lines and they want you two points and they want you to find the gradient of, they want you to find the equation of the line. So let me help you with these ones now. Here's the last thing. So we can open up here, we are finding the equation of the line given 1 point and the gradient. So Let me show you how to calculate the gradient now, given 2 points. So let's do it like this. Calculating the gradient. So when I'm calculating the gradient, given 2 points, if I have x1 and y1 as my point, as my first point, I also have the second point as x2, y2 as the second point. I can find the gradient. By saying y2 minus y1 divided by x2 minus x1. This is basically how I treat it. Yeah. So giving an example, let's just take the one that we got in this question. We have A is 0, 5 and 3, 11. 0, 5 and 3, 11. So 0 and 5. Then we have 3 and 11, like this. So to find the gradient here, I'll just say y2, which is 11, minus y1, which is 5. All divided by x2, which is 3, minus x1, which is 0. So here at the very end of the day, I get 11 minus 6. 11 minus 5, that's going to be a 6. Divided by 3 minus 0, that's a 3. So my answer is 2. So 2 becomes my gradient. Pretty simple, yeah? So check this out. I can be asked now to find the equation of this line that is passing through this point and this point, right? The equation of the line now. So I already have the gradient, and I can pick any one of these 2 points to get in this space. I already have the gradient, which is 2, and I can pick any point here. I can take this or this to find my equation. Either way, that will work. So let's just pick this point first. If I pick this point, y is equals to mx plus c. I know my m is 2. So that's 2 of x. X is 0. Y is 5 plus c. So to find the value of c, 5 is equals to c, because 2 times 0 is 0 here. So I will write my equation as y is equals to m is 2 to x plus c. C is 5. This is my equation of a line. So let me test again with this point. Y, this is my m, so my y, this is my x. So we are now saying what? 11 is now equal to m, which is 2, x, 3 plus c, which I don't know. So now I have 11 is equals to 6 plus c. I take the 6 to come to the other side. 11 minus 6 is equals to c. So my c again is still coming through as 5. So I now substitute this in my main equation. Y is equals to m. I got my m as 2, x plus c, 5 now. So this now becomes my equation, just like how we did here. So you pick any one of these 2 points to become your point, in the gradient you'll be using this. I hope you understood how to calculate, first of all, to identify the gradient, then to identify the y-intercept. Second of all, I hope you were able to calculate the equation given 1 point and 1 gradient. Again, calculating the gradient given 2 points, and again, calculating the equation of a line given 2 points. That's what's up.